minus 3. Now, maybe you're allowed to use a calculator. Maybe you're allowed to use Desmos. I'm not sure. But
I
I
don't
would
think
graph
so.
as you go. Yeah, I would graph as you go. I would not wait until the end to graph. There's just too much going on there. All right, so next thing are the horizontal asymptotes. Okay, and this comes from, and you really want to go back to the unfactored form of this. Sometimes you want the factored, sometimes you want the unfactored form. The horizontal asymptote, there's three cases that you probably saw in class. It's based on the degree of the numerator and the degree of the denominator. Do you remember any of those from class?
Isn't it like top heavy, bottom heavy, and equal?
Okay, I like that. Yeah. So would you consider this one bottom heavy or top heavy?
Bottom heavy.
Right. So if it's bottom heavy, this is always y equals 0.
Okay.
And that's another line to draw on the graph there. Okay. So y equals 0 like that. Now there's another thing that I do, and I don't, if you don't like this, we'll just try it one time here. But this thing that I like to do here is I actually like to draw these arrows next to all the asymptotes, because we're going to connect some of them at some point. And we'll do this connect the dots here in a bit, but we'll come back to that. The next thing that it asks for is to find the holes, and holes actually come much earlier. They're actually better. It's better to do holes after you factor.
Mm-hmm.
I'll show you why here in a moment if we see one. But if we go back to the factored form, you're looking for the same factor on the top and the bottom.
Yeah.
And that this does not have that. What you're looking for is same factors, top and bottom. So this one does not have any. So we can say none. Okay, y-intercept. Y-intercept. That's when x equals 0. Okay, so you have to put 0 in for x. And you can go to either the original or the factored form of this. I'd probably use the original form. 0 minus 4 over 0 squared plus 0 minus 6. And after you do it a while, you do this for a while, you realize that it's just the last one over the last one, which is 2/3. So that's our first data point. It's 0, 2/3. So if you go back to the graph, it's tough to see. I'm going to do it in red just so it's a little bit more visible, but kind of right there is a dot. Okay, so at least we got the dot. And then the last thing is the x-intercept. The x-intercept comes from setting f of x equal to 0, but more generally, this comes from setting the top equal to 0. Okay, so setting the numerator x minus 4 equal to 0, solve for x, x is 4. So that's another data point. When x is 4, y is 0. So we'll go back to the graph and plot that point on there, 4, 0. Okay, here we go. To graph it, there's a little bit that there's a little bit more that needs to be done. This is a pretty tough one to kind of start out. Normally get a little easier one than this, but you need to get some more information. Like normally you've got some information like, well, like does it come down from like this one, cross there and cross here? Well, or does it come down and cross, or can it cross? So you need a little more information. So that there's some rules to go off of. It can never cross the vertical asymptotes. Never, never, never. Okay. It can cross the horizontal ones, although it's rare, but it can cross it. Okay. One of the things we can do, because there's no x-intercepts between the two vertical asymptotes, we know that this actually comes down and comes back up because we know that it cannot cross here.
Yeah.
All right. That doesn't help a ton with the other ones. For the other ones, you have to test a point in the region. So on the one on the left here is going to be a little bit easier. You have to test something between -3 and -infinity. basically you want to put that back in here and you want to find out whether it's positive or negative. That's why I ask if you're allowed to graph these things using another tool, you don't actually have to test points, but this is the most difficult part of it. So let's just test, for example, let's keep it simple, test -4. Okay, so that's putting it back into the original equation. So that's -4 over -4 squared plus -4 minus 6. All right, and that becomes -8 over 16 minus 6 minus 4. So what did I say? 10. So over 6. So notice that this is a negative number, -4/3. So that point, you need that point in the graph here. It's -4, -4/3. So somewhere like there. And like I mentioned, they generally don't cross the horizontal or the vertical asymptotes. So it actually starts down here and looks like that there. That's why you need that point, because it could have been this line or it could have been this line here.
Yeah.
All right. There is some symmetry to take advantage of potentially, but it's better to test points. So in this case, we probably want to test something between the vertical asymptote and the 4, so maybe 3. Test 3. And I'm doing a lot of scrolling here. We gotta just running out of room. Let's test x equals 3. So that's 3 minus 4 over 3 squared plus 3 minus 6. That's
Can you
negative.
also plug it into like the factored form?
Yes, yes. If you prefer the factored form, do it. Whatever you like. We just need to know whether it's positive or negative here. So I get a -1/6, and so that is 3 -1/6. That's here. That tells us that it has to, the only way, because it can only cross once, and then it comes back kind of down there like that. But really a tough one to start out. I don't
Wait,
envy.
how do we know that it crosses over though?
It has to, at the intercept, it has to cross. It has to cross there. So this 3 -1/6 was down below. So the only, because it can't cross anywhere else, it can't come from the top and cross to hit it. We know that it had to start down here to get to it. So it's kind of a connect the dots, certain dots to get that.
Okay.
This is not the best example that I wouldn't have started with this example if we're in a classroom. This is a very elevated problem for us.
Yeah.
All right. So hopefully doing another example will make this more clear. Let's take a look at a new problem here. So first thing to do, factor. Will you factor the numerator for us, please?
Yeah. Is it x minus 3, x plus 4?
It is very good. All right, now I know that the list says to do domain first. You actually do domain, and then you look to see if anything cancels. So you can kind of visually inspect that here. So the domain on this one, you set the bottom equal to 0, only the bottom. X is 4, and this is a restricted value. It cannot be 4. So it's all the numbers except for 4 on the number line. So that would be -infinity to 4, union 4 to infinity.
Okay. And is that because it's on the bottom?
Yes, the domain always comes from the bottom. Okay. So after you do the domain really leads you to the holes. And you're looking for, like I said over and over again, because what'll happen is if I don't remind you here, you'll get to a test or quiz, there'll be a hole and you'll forget. It really changes everything. Any
Yeah.
common factors in top and bottom. This one does not have any, no holes. But it does have vertical asymptotes. The vertical asymptotes are again where the bottom equals 0. So where x minus 4 equals 0 or x equals 4. Right. So this one, I would immediately graph that. It's probably a little easier for you because it's right there on the page. X equals 4, some sort of a dashed line there through that. Any questions on that? All right, so really like the way you presented it for horizontal asymptotes, top heavy, bottom heavy. This one is top heavy.
Yeah.
And since it's top heavy, that means that you have to actually use division, synthetic division or long division here. Do you have a preference for that?
Synthetic division.
Okay, so and what we're looking for is the what's called the oblique or the slant asymptote. Oblique just means it's sideways. It's not horizontal or vertical. So the coefficients go here, and then you bring down the 1. Okay, the reason 4 goes in the box is because x minus 4, the 4 makes it 0, so that's why it goes there. Times 4, add up, times 4, and this is 8. So you're actually not interested at all in the remainder. You're actually interested in the coefficients this time. Typically, I don't know why there we go. Typically, you're looking at the remainder, but this means 1x plus 5. Is that okay? Because this one was x squared, so when you divide, it goes down to x.
Yeah.
All right. 1x plus 5, that's the equation of the oblique asymptote. So you want to graph that. Goes through 5. It's got a slope of 1. So you want to do your best to kind of make that as nice as possible. Something like that. Have you seen this before in class?
Yeah.
All right. Any questions on what we've done until now?
No.
Okay.
That all makes sense.
Great. So the next thing is the y-intercept. From the last problem, you know that the y-intercept comes from making x equal to 0. Will you calculate the y-intercept for us, please?
Isn't it just 4?
It's negative 12 over negative 4.
Never mind.
Right? You got to put x 0 in the top and the bottom. What would that? Yes. So x is 0, y is 3. So I'm going to go switch to the red color here, just make it easier to see. But there you go. There's your y-intercept. You can also, again, kind of put these lines on the asymptotes to kind of figure out like what's going to happen here. All right. So the next thing is the x-intercept. Set the numerator equal to 0. You're setting f of x equal to 0. That's the x squared plus x minus 12 equal to 0. That's where it's so much better to have the factored form like you did earlier, x plus 4, x minus 3. You can wait to do it, but it's really better to do it from the beginning so you can get the holes if there are any. But you can see that this has 2 x-intercepts. What would those be?
Negative 4 and 3.
Negative 4 and 3. So that's here and here on the graph. Write those in. So now we go back to the graph. We've got some good stuff here. Like we don't have to kind of guess and test points. It can only cross the x-axis at an x-intercept. It can only cross the y-axis at a y-intercept. So this has to kind of work like that. Okay, and then they have to attach to an asymptote. So it looks something like that.
Okay.
Now the question is, well, what do we do in the region in the right here? And the if you've done a bunch of these, you will eventually realize that it's always opposite, like diagonal, kind of lower left, bottom right, or right and top left. If you're not sure, you could test a point. When you test that point, though, you'll get something up here, and you have to make sure that you know that it's above this line. But again, keep in mind, you can't start down here because it can't cross. There's nowhere for it to cross to get up here.
Yeah.
And this could be a little smoother. I mean, it's better to use the computer if that's an option, but maybe it's not. All right, any questions on that before we go to 2A or 3?
No.
Okay. All right. These are really tough. These are really, really tough because you're barely comfortable. You're barely comfortable, graphing these things. And now they want you to use the graph to come up with the equation. So pretty tough here. You must be in an honors class. All right, so we'll go through this piece by piece here. Vertical asymptote at x equals 4, x equals -2. So I'm drawing this horizontal line. Does the vertical asymptote correspond to the top or the bottom? Do you remember?
Bottom.
The bottom. Okay, and the first one is x -4. The second one is x plus 2. So bless you. So we've taken care of that one. We're making some progress here. All right, we'll come back to the horizontal asymptote. The x-intercepts, so this was the denominator. Do you remember what the x-intercepts refer to? Are they the numerator or the denominator?
Is it the numerator?
The numerator, yeah. So they're saying there's one at x equals 1 and x equals 0. That again corresponds to x -1. And you probably wouldn't write it this way, but I'll show it this way for the first one, x -0.
Okay.
So we've gotten that down. We'll come back to this whole business in a minute. Horizontal asymptote at y equals 2. Does that mean it's top heavy, bottom heavy, or the same?
Top heavy.
So top heavy was like the last one here, where it was bigger on the top than on the bottom, and it was an oblique or slant asymptote. Y equals 2 is just a horizontal line. So if it's bottom heavy, like the first example we did, sorry for scrolling here. If it's bottom heavy, like the first example, it is y equals 0.
So it'd be equal?
It is equal, yes. All right, so in this case, when you multiply x times x, you get an x squared, x times x, you get an x squared. This is already equal, so we need to put a little 2 above there.
Okay.
That's where that part comes from. Now we have yet to do this today, but I've been alluding to it quite a bit. This whole at x equals -3, that means there's a factor that cancels in the top and the bottom, like that. Do you see how these would cancel if we were having it in factored form? That's your so that's part of it, even though it cancels. Like I could see maybe making the argument or asking a question like, well, why would I even write this if they just cancel? Well, it's because you're supposed to FOIL and then multiply, and then you wouldn't see it. Same thing down here, you might FOIL and then multiply, like that.
Okay.
So basically this problem is about you knowing, okay, vertical asymptotes affect the bottom, x-intercepts are the top, Poles are factors that cancel. Horizontal lines, top heavy, bottom heavy, things like that.
Mm-hmm. Is that it?
That is it.
Okay.
Now this is
Not
not
too
this is
bad.
not simplified though. Like this, but it doesn't give you any instructions. It doesn't say to leave it in factored form or not. You know, you might ask your teacher, "Hey, I worked through 2A and I wrote it in factored form. You know, is that okay?"
I'll check the answers and I'll say. And I bet if he didn't like clarify, then it's probably factored form. I'm good for the next one when you
Okay, sorry. Yeah, didn't know you were waiting.
were.
All right. That's also the awkwardness of Zoom sometimes.
Yeah.
Yeah. All right, here we go. Letter B. Vertical asymptote at x equals -1. So what does that affect here? Is that the top or the bottom?
Isn't that the bottom?
It is the bottom. What would go on the bottom for that?
X plus 1.
You got it. Now we're not given much more information. It just says an oblique asymptote. That means, and I really like this, top heavy.
Yeah.
And bottom. And people sometimes say, don't you get tired of teaching some of the same? Like, no, like I actually learn stuff, like
Yeah.
new ways. Like this is gonna be so useful for me when I talk to other students now. That's why
Oh,
I'm
good.
very excited. So all you got to do here is come up with something on the top. And what most students do is they try to overcomplicate this. This is sufficient right here. This is now top heavy. You don't need to add anything else here. You don't need to. Things like that. All right. So on to 3. So we're going to start with the graph on 3 and work our way backwards. Do you feel like 3A is correct? Like, do you want me to check that or just move on to B?
Could you check that? Because I'm not really sure. Because my friend was just like, I'm pretty sure it's this. And I was like, oh, okay.
All right. Well, so the way to check something like this is to go from the equation and just see if it's right. So vertical asymptote at -2 and +1. That looks good. You've got an x-intercept at 0 and -3. That looks good. The question is like, well, does it actually connect like this? And this one could be good. This one, not sure about. So we really should have tested points in each of those regions. So like we should have tested, because we don't have enough information, we should test something like -4, something between -2 and 0, so like -1, and then something between 0 and 1, so like 1/2 there, which isn't great, but actually we can get away with just the -1. And then you would want to test something over here. So let's say 2. All right. So for the -4, it's -4 times right out here, -4 times -4 plus 3 over -4 plus 2, -4 minus 1. So I don't like the factored form as much, but it's maybe more, looks better. This is -1 times -4 is 4. And then this is -2, -5. So that's 10. So it's 4 over 10 or 2/5. So that looks good. This one looks good over here. -1, we've got, do that one down here, -1 times -1 plus 3 over -1 plus 2, -1 minus 1. Numerator is -2, and then 1 over or 1 times -2. So this one's actually positive. So I believe this is going to actually look like this here. And then we can test the last point here. Again, the other thing you could do, I know you can't do this in your class, but since it's for homework, you could use Desmos to check. But when you try 2, you get 2 times 2 plus 3. You get over 2 plus 2, 2 minus 1. So the numerator is positive. It's 10 over 4 5/2. All right, something like that. So it would actually be up here like this.
Okay.
So let me just double check this here. Sometimes it just looks right and it really is way off. X is 2. X. All right, actually, there's another thing. So we actually did need to test this other point in the middle. Sorry, I'm losing my mouse. So this one is actually not correct. We really did need to test that 1/2 as well, and that'll give you this like this.
Oh, okay.
So there's a bit more to do here, but this is the graph, isn't it? This is the graph they want, or
Yeah,
not?
we're trying to find the
Okay, yeah. So
function
probably
for the
we
graph.
should have done that. This if this is truly what they want, we have to make some modifications here, and
Yeah.
trying to think here how to suggest we do that. Okay, let's start over.
Hmm.
All right, so start over here. Forget about this for a moment here. Some of it is correct. You do need something at X. Is that 2? Yeah, X plus 2 and X.
-1.
Okay, so is that one at -2? Yeah, -2. Sorry, just getting to where I can believe this. That's fine there. Okay. And then so this part means this part right here, if when it touches at 0, that means there's an X squared in the top, because if it touches, it has to bounce. And that's where I think part of the issue is going to be here,
Mhm.
like that. But only one there at X plus 3. And Y equals 0. So we've got to, is there any chance this graph is not correct? Because this one's really hard to actually produce as is.
I don't know. I think that's like what he wants.
Okay. All right. Let's come back to this. If you don't mind. This is, there's something not right about this. We'll see it maybe on the next one, because it looks hand drawn and it's got a horizontal asymptote at 0. That takes care of that. Maybe it. And there's nothing else here. Like we're looking for a hole, something else. There's no hole.
Okay.
All right, let's just do the maximizing our time here. Let's go to B, see if we can do a little better job with this one here.
Okay.
Come back to that in a moment. All right, so the couple of key features here. This hole is a pretty big deal.
Yeah.
The hole is at X equals 4. Okay, and that means that there's going to be something on the top and bottom. There's going to be something on top and bottom that's the same. So there's going to be an X minus 4 on the top and an X minus 4 on the bottom. All right. There's a bit more to that though. The Y value we have to also get, but we'll get to that later. The next will be the 2 vertical asymptotes. So there's one at X equals 3 and X equals minus 2 here. So those are going to go on the bottom of this. So that's x minus 3, x plus 2. Okay. And then we see that they're giving you an intercept, 2 x-intercepts. They're giving you one here at 1 and at minus 9. So x-intercept at 1, minus 9. So that's x minus 1, x plus 9.
Where'd you find the -9?
Right here.
Oh, okay.
Yeah, it's kind of awkward because this horizontal one looks like it's the axis, but it's not. And there's a horizontal asymptote at y equals 1, which is consistent with what we have here because the 1 over 1 for that.
What about the smaller point? That's like
This one, the y-intercept.
oh
There.
yeah.
So we're going to see, I'm going to just quickly check that this is right before going any further with the graph, because we don't need to have any more issues. So let me quickly graph this. All right, there's that. And then on the bottom, it's 4, x minus 3, and then x plus 2. Okay, and so this does do it. This actually is the graph here. This has got everything that that you're looking for on this one. So this y-intercept, the way you would check it is put 0 in for x. Now, because these cancel, you wouldn't have to worry about that, but it would be minus 1 times 9, which is minus 9, minus 3 times 2, which is minus 6. So minus 9 over minus 6 is 3 halves. That's kind of about where that one is there.
Okay.
All right. Do you want us to go back and try the other one now?
Sure. Or we can go over one A and B on the front side and then do that one.
I think we can get the I think the graph can be got. I just need to not look at what's there when I do this. Sometimes having the answers worse or somebody else's work, because you're trying to figure it out what's going on here. Yeah, so here we go. We've got x equals 1 and x equals minus 2. Okay, so that's x plus 2, x minus 1 at the bottom. This one has to be bottom heavy because its intercept is at, or its y equals 0. So it has to be bottom heavy. So the question is does that actually hit there at the origin? And it must, I guess, although that suggests, that's where I keep, that suggests there has to be something else going on here. Does that look right on the origin to you?
It kind of does, yeah.
Okay. Yeah, I kind of agree. So the intercepts are x minus 0, and then x, this other one here at plus 3. In this form as is, it's equal. The top is x squared, the bottom is x squared. So there's no way to get the y equals 0 without adding another term down here. That's why I'm sort of asking, like, what's going on? How can this be? And you do not have the solution to this one?
I do. Let me go grab my computer really quick.
All right.
that one, he put negative 16x squared, x plus 3, 5, x plus 2 squared, x minus 1 squared.
Okay, yeah, and that is actually the direction I was going here on this. So because this one touches, the one we have has to be a square. Okay, that's for sure. And the issue is now the fact that it's now top heavy. So that means you have to do something to the bottom, and that's why these were squared to now make it bottom heavy, which gets you the 0. And then if you were to graph this as is, you would find it's actually all flipped. And so that's where the negative comes in. I think the 16 is like a arbitrary value. But you might ask how you were supposed to know to square these, because generally that's not emphasized when you're doing these types of problems. But the fact that it touches right there, that's what that square comes from, because it touches.
Okay.
All right, so we got some time left here. You said, go back. We got, it looks like you've done 4. Do you want me to check any of these, or do you feel like they are correct?
I feel like I'm pretty confident on those.
All right. Greater than 15. That's true. One on the left. Should be 2 windows. C, I believe you might be missing a window. I would have to graph it to know for sure. Do you want me to check C for C? Or do you feel like you? Okay. All right. Let's grab a snip of that. So I like what you've done here, where you've created this number line, and you do have to break it up both where it's 0 and where it's undefined, but then you test a point in each of these regions to figure it out. And they it doesn't always work out the way you think. So you just try it. You just put the numbers in and see if it works here. So this one is positive, this one is negative, and this one is positive. So your answer does look good there, the way you've got it.
Okay.
For D is a little more difficult. Do you want us to work that out or move back to?
Yeah, you can.
Okay. All right. So to do D, you really want the one side of the equation to be equal to 0. So you really do have to subtract 2 from both sides. So that looks like this: x plus 2 over x minus 3 minus 2 less than or equal to 0. You might be wondering, what do I do now? Well, you have to make a common denominator, and your common denominator is going to be this x minus 3. So I'm just going to move this over a little bit, and we're going to multiply the top and bottom by x minus 3. So now it will have a common bottom.
Yeah.
So it's going to be on the top minus. At some point you want to combine the minus with the 2. Let's do that now. So it's negative 2 times x minus 3 over x minus 3, x minus 3 here, x plus 2 here. And then you distribute that negative 2. So in the numerator of x plus 2 minus 2x plus 6 over x minus 3. So your numerator becomes minus x plus 8 over x minus 3. And then you do the same thing you were doing in the last problem. You make a number line and you say, okay, at 3, there's gonna be 2 points. 3 for the bottom, that's where it's 0. On the numerator, it's 8. That makes it 0. And you have to test each of these regions. Maybe test 0, 5.
Would it not be negative 8?
Looking at minus 2 times minus 3 is positive 6 up here. You distribute that negative to both.
Okay.
So that's 2 and 6, which is 8. X minus 2x is minus x right there.
Okay.
All right, so that now when we test these points, the first one, 0 plus 8, 0 minus 3 is 8 over minus 3, which ends up being negative. The middle point here, minus 5 plus 8 is positive 3. 5 minus 3 is 2. So you have a positive or a positive, and that's positive. And then at 10, minus 10 plus 8 is negative 2. 10 minus 3 is a positive 7. So it ends up being negative here. The other thing to do in this problem is to recognize that at 3, it's an open circle because it's undefined, but at 8, it's a closed circle because it's perfectly, 0 there. And we're looking for where it's less than or equal to 0. So you have to be really careful here with the, the interval notation, minus infinity to 3, but with parentheses, bracket 8 to infinity for that one on the right there. I assume you're doing this test point stuff in class.
Uh-huh.
Okay. All right, so we can go back and look at A if you want here.
Mm-hmm.
All right, so let me snip in your work here. All right, so the domain comes from setting the bottom equal to 0.
Okay.
So notice that if x is 0, it's you're dividing by 0. So 0 is excluded. So it's everything but 0 this time. So it'd be negative infinity to 0, union 0 to infinity. Like that. You did get the vertical asymptote correct. That's great. And the horizontal, you really should specify here, and I didn't do that earlier because they're not the same. It's not horizontal / oblique. It's one or the other.
Yeah.
But that is correct. It's equal. There are no holes. That's true. The y-intercept is when x equals 0. Sorry, that's correct because you cannot divide by 0. And the x-intercept, good with that. Okay. So quick sketch, right? Let's do that here. Grab the snip here of that. That's not what I wanted. That's what I wanted. So vertical asymptote at 0, horizontal asymptote at 2. And then we know that it crosses at 3 and no y-intercept. So this one's going to have this shape and then the shape like this here, which you can find by testing points. All right, we do have to stop there for today.